Okay, let's take a look at Chapter 8, Quadratic Equation, Functions, and Inequalities. Remember, a quadratic equation is of the form ax squared plus bx plus c equals 0. Most of you may recognize that that is a parabola, which may cross the x-axis 2 times. It may cross or just come down and touch the x-axis, or it may have no solutions whatsoever, meaning it doesn't intersect with the x-axis at all. Quadratic is of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers. We're going to use the zero product property to solve these equations, and that is if a times b equals 0, then either a is equal to 0 or b is equal to 0. Strategy for solving a quadratic equation by factoring is to first write the equation with 0 on one side, factor the other side, use the zero factor property to set each equation equal to 0, solve these two simpler equations, and then check your answer in the original equation to make sure that it is true. So according to the strategy, we are going to just subtract 15 from both sides. So now I have everything on the left-hand side, I have it set equal to 0, and now I can factor this. You can use the rainbow method, or if you're more comfortable with guess and check, you can use that. So if you think of how can you factor 3x squared? The only way to factor that is 3x times x. And then the factors of negative 15 are going to either be negative 5 and 3 or positive 5 and negative 3. You can substitute those in and then check that back, mentally foil that back and see if you have the correct answer. In this case, I would have 3x squared minus 9x plus 5x. That gives me my negative 4x. Okay, the next step is to take each of these simpler equations and set them equal to 0. Remember the zero product property. This represents A, this represents B. If the product is equal to 0, one of those two must be equal to 0. Solve each of these for x. So the first one, I get x is equal to negative 5/3. The second, x is equal to 3. So the solution set, x is equal to minus 5/3 and 3. Remember the even root property. The even root property says that n is a positive even integer. If k is greater than 0, then x is equal to plus or minus the nth root of k. If k is equal to 0, then x to the n equals k, means that x is equal to 0. If k is less than 0, it has no real solutions because then you'd be taking the square root of a negative number. So the even root property allows us to solve these quadratic equations when they're in the form of a binomial squared. So to solve this, a minus 1 squared equals 9. Take the square root of both sides. So a minus 1 is equal to plus or minus the square root of 3. As you can see, k, the value k, is greater than 0. So I'm going to get two answers, plus and minus. Sorry, plus or minus the square root of 9. Make that a 9. Okay, so I get a minus 1 equals plus or minus 3. Add the 1 to both sides. A equals 1 plus or minus 3. So a is equal to the solution set negative 2, 4. Now, not all quadratic equations can be factored. However, we can write any quadratic equation in the form of the last example and then apply the even root property. And the process for doing that is called completing the square. The key to completing the square is to recognize a perfect square trinomial, and to get it in that form, what we literally do is geometrically complete the square. If I look at this diagram, and this length is x, this length is x, it gives me an area here of x squared. This is 1 unit, 1 unit, 1 unit, 1, 1, and 1. So the area of each of these long bars is x. So you can see that makes up my x squared plus 6. The idea of completing the square is literally adding to those first two terms the number of units required to complete the square. 1, 1, 1, 1, 1, 1. So we're literally going to add 9. We're literally completing the square. Now you won't need to do that diagram because we have an algebraic way of completing the square. That was just so you could recognize you literally are completing the square. Now you have x plus 3 times x plus 3. So you have x plus 3. The binomial squared generates x squared plus 6x plus 9, which is that perfect square trinomial. The rule for completing the square is to find that last term. The last term of the perfect square trinomial is the square of 1/2 the coefficient of the middle term, or the second term. In symbols, the perfect square trinomial whose first term is x squared plus bx becomes x squared plus bx plus b over 2 squared. So we're literally taking that second term, dividing by 2, and squaring it. In the following example, that means I have x squared plus 8x plus 8 divided by 2 squared. So x squared plus 8x plus 16. That's my perfect square trinomial. I want to write that as a binomial squared, so that becomes x plus 4 squared. Next example, I have x squared minus 5x. So I'm going to add to that 5 divided by 2 squared. That gives me x squared minus 5x plus 25 fourths. My binomial squared is going to be x minus 5/2 squared. If you want to understand what sign you should put in the binomial, you need to look at this second term, and that will indicate if it's positive, it will be positive, and if this is a negative sign, it will be negative. Example C, I have x squared plus 4/7 x. I'm going to add 4/7 divided by 2. That's going to give me 14, or 4/14. 4/14 will be 2/7 squared. So my perfect square trinomial is x squared plus 4/7 x plus 4/49. Writing that as a perfect square trinomial, or as a binomial squared, I have x plus 2/7 squared. Finally, D, I have x squared plus 3/2 x plus 3/2 divided by 2 will give me 3/4, and then I'll square that. So my perfect square trinomial will be x squared plus 3/2 x plus 9/16. Writing that as my perfect square, or my binomial squared, I have x plus 3/4 squared. So again, each one of these is a perfect square trinomial that we're going to write as a binomial squared in its factored form. So now let's look at using this idea of completing the square to actually find the roots or the x-intercepts for a quadratic equation. I have x squared plus 6x plus 5 equals 0. First thing I'm going to do is subtract 5 from both sides. So I have x squared plus 6x equals minus 5. Then I will add to both sides b divided by 2, so 6 divided by 2 is 3, 3 squared is 9. So I will add 9 to both sides. I'll rewrite the left-hand side as a binomial squared. X plus 3 squared equals 4. Now I can use the even root property. Take the square root of both sides. X plus 3 is equal to plus or minus the square root of 4. X plus 3 equals plus or minus 2. Now solve for x. So x is equal to negative 3 plus or minus 2. That generates the solution set. X is equal to negative 5 and negative 1. So if you had to begin to sketch this graph, you would know that the x-intercepts occur at, this is at negative 1 and negative 5. Remember, a parabola is symmetric. It actually reflects about this line called the axis of symmetry. That's this line. We're going to talk more about that later this week. We'll be able to find the vertex, the axis of symmetry, and the x and y intercepts later on in the chapter. Okay, strategy for solving equations by completing the square. If a is not equal to 1, then you must divide each side of the equation by a. That's really important. If you don't do that, you will not get the correct answer. Get only the x squared and the x term on the left-hand side. Add the square of 1/2 the coefficient of x to each side. Factor the left-hand side as the square of a binomial. Solve for x and then simplify. So in our first example, we're going to take 2x squared plus 3x minus 2 equals 0. I have to divide out that 2, so I would get x squared plus 3/2 x minus 1 equals 0. Now get just the x squared and the x term on one side, the constant on the other side. So I have x squared plus 3/2 x equals 1. Take that coefficient on x, that's the b, divide that by 2, so I get 3/4, and add 3/4 squared to the left-hand side, add 3/4 squared, which is 9/16 to the right-hand side. Now that I have an equation, whatever I do to the left-hand side, I also have to do to the right-hand side. So when I add that third term to make my perfect square trinomial to the left, must also do that to the right. Now on the left-hand side, write your perfect square trinomial as a binomial squared. Combine like terms on the right-hand side, and you'll get x plus 3/4 squared is equal to 25/16. So then take the square root of both sides. X plus 3/4 is equal to plus or minus the square root of 25/16. So x plus 3/4 equals plus or minus 5/4. Then subtract 3/4 from both sides. So x is equal to negative 3/4 plus or minus 5/4. So your solution set, x is equal to negative 3/4, negative 5/4 is negative 8/4, which is negative 2, and then negative 3/4 plus 5/4 gives you a solution of 1/2. So the x-intercepts for that particular quadratic are at -2 and 1/2. And you have two rational solutions for that equation. Number 2, we're going to get irrational solutions. So let's take a look at completing the square for number 2. We have x squared minus 3x. Again, I'm going to add that constant to both sides. Take the term b, divide it by 2, so 3/2 squared. On the right-hand side, I'm going to add 9/4. On the left-hand side, I'm going to write that perfect square trinomial as a binomial squared. And I will get a least common denominator on the right-hand side so that I can combine like terms. So I have x minus 3/2 squared is equal to 33/4. Now use the even root property and take the square root of both sides. So I have x minus 3/2 is equal to plus or minus the square root of 33/4. Remember the property that says if I have the square root of a over b, that's the same as the square root of a over the square root of b. So I can simplify that right-hand side. X minus 3/2 is equal to plus or minus the square root of 33/2. Add the 3/2 to both sides, so x is equal to 3/2 plus or minus the square root of 33/2. So your solution set, x is equal to 3 plus root 33/2 and 3 minus root 33/2. You can leave it just like this if you wish. But you should recognize that there are two solutions. Those are the 2 points that this parabola crosses the x-axis. And there are 2 irrational solutions. Number 3 has only imaginary solutions. So let's take a look at this. I have x squared minus 4x is equal to -12. So I will add 4 to both sides. Write the left-hand side as a binomial squared. X minus 2 squared equals -8. Use the even root property to take the square root of both sides. So x minus 2 is equal to plus or minus the square root of -8. I can rewrite that as x minus 2 is equal to plus or minus 2i root 2. Add the 2 to both sides, x is equal to 2 plus or minus 2i root 2. Again, you can leave it in this form, or you can write it as the solution set 2 minus 2i root 2, 2 plus 2i root 2. And that completes the notes for section 8.1, the first section on factoring and completing the square. The homework is listed. I hope this video helps. See you tomorrow.